All right, crew, this is day 2 of describing numbers. So we're still going to be looking at that reference chart, that graphic organizer that's going through the different types of numbers. Yesterday you looked at categorizing the first 3 here, natural, whole, and integers. So today we're going to be looking at decimals, which, guys, are not those numbers that we're the most comfortable with. So we're actually ignoring those top 3 categories of our organizer, and we're jumping right down to rational, irrational. So I want you to be focusing on the bottom portion of this graphic organizer. So if we look at the definitions, it may seem kind of straightforward, but when we really get into it, it can be a little bit difficult. So I'm going to try to break it down as simple and as few of steps as possible. So if we're looking at a decimal, if I'm asking you to describe 3.5, right? Here's the characteristics that would make it rational. If our decimal has an ending spot, if it has an end to it, so 1.8 has a distinct end, and 7.896, again, there's an end to my decimal. Those are considered rational numbers. The other type of rational number is if we have a pattern in our decimal. So here's my first example, 0.66666. So that number goes on to infinity. That's what the dots after the decimal mean. Or have a pattern. So again, this has a repeating value to it, but this time it's 4.25252525, and again extends beyond. So if there is a distinct end to our decimal, or if it has a pattern to its a repeating pattern to it, then it would be considered rational. The other type is irrational, and it is exactly the opposite. So irrational numbers are not decimals that have a pattern or an end. So these oftentimes you will see with the dot, dot, dot if it's written down on paper, but there's no rhyme or reason to that decimal. Except 4.745843, no pattern, and it doesn't end. And the second example, same kind of idea. There is a crazy number, random number that is after the decimal. Those would be irrational. So let's take a look at some examples. So again, these have a lot less descriptors. Our numbers are either going to be, our decimal numbers are either going to be rational and real, or irrational and real. So if I look at 3.5, you're asking yourself, does it have an end? Does it have a pattern? My answer is yes. So it should be rational and real. Rational and real. All right, 7.44444444. So there is definitely a repetitive part after our decimal. 44444 is the same as a repeating pattern, right? It is also rational. So if I was going to drop in my ball, I would go into the rational bucket and it would fall down to real. So number 1 and number 2, our first 2 examples, although they look different, they're actually both rational and real. Those are descriptors that we would describe both of those numbers. So take a look at the last one here, 4.92734, right? There's a bunch of random numbers there at the end. There's no pattern, and this ellipse, this dot, means that it continues on forever. So it is actually our example of an irrational number. So again, if I drop it in, it's irrational and real. So just to type that in, we have this number is considered irrational and real. Those would be our descriptors for it. So this, guys, I'm just having you look at those decimals and determine whether or not it is rational and real or irrational and real. The choices are much less. So on your practice example, you're going to have to just tell me what type of values and what descriptors you would give for each number that I give you. All right, good luck and reach out if you need help.